This is part 2 of our video on the chain rule. When we left off, I asked you to look at the 2 examples that we had and see if you could come up with what you thought the derivative of c of x was. So when I did it, I thought that the derivative of c of x should be 18x times 10 times 9x squared plus 5 to the 9. And then when I multiplied the 18x and the 10, I got 180x times 9x squared plus 5 to the 9. And I will briefly explain where I got that from. So when I looked at my examples, I noticed when I tried to compare the highlighted parts that the end part, right, 3x plus 5 to the 7, that matches that bracket, 3x plus 5 to the 7, but it didn't have an exponent. It actually had a secret exponent of 1. And that 2, that exponent, ended up in front of the bracket. When I looked at the second example, I noticed the same thing. I had 5x minus 1, and then instead of the power of 3, we had the power of 2, and that 3 ended up in front of my bracket. So that's how I did the first part. Actually, the second part, I looked at the 9x squared plus 5 to the 10, so I said it should be 9x squared plus 5 to the 9, and then we would have multiplied by 10 there. And then I also stopped to figure out where this was coming from. So the 15x to the 4 is actually the derivative of 3x to the 5 plus 7. And here, the derivative of 5x minus 1 is just 5. So I decided that the derivative of 9x squared plus 5, 9x squared is just 18x, and then the derivative of 5 is 0. So it would be 18x, which was the derivative of the bracket, and then times, all right, our bracket with 1 less on the exponent and the coefficient down in front. Okay, so chain rule. Chain rule works in a lot of different cases, but for us today, it works really well when we have a bracket. So what we're going to do is we're going to try to write our function as a composite function. So I said f of x is g of h of x. So basically what I'm trying to do is recognize that there is something inside the bracket that we are going to have to deal with, and then there's the whole outside function that we're going to have to deal with. So when we did the derivative, I did the derivative of what was inside the bracket. So what's inside that bracket is h of x. So the derivative of h of x would be h prime of x, right? So we take the derivative of what was inside the bracket. And then this is really just kind of power rule, right? You have the bracket, you take one off the exponent, you multiply the coefficient by whatever's in front, right? That was how we did power rule. We did the exponent times the coefficient, and then we took one off of the exponent. So we're really multiplying this by the derivative of the outside function, so like the actual power with the bracket there, of h of x. Right? So with that inside still in there. So I am just going to make a little note. The notation is a little weird, that this is the derivative of the bracket, and this is the derivative of the whole function. Okay, so we are going to try some examples and try to see if we can follow our rule for the chain rule. Okay, let's take a look. So I just dropped my marker. It says differentiate using the chain rule. The word differentiate is a fancy word that just means take the derivative That's all that means. Just means take the derivative. So it says differentiate using the chain rule. State your final answers in simplified factored form. So I have f of x is 5 plus 3x to the power of 10. So I probably wouldn't try to use power rule here, because in order to use power rule, I would have to multiply all of that out. So I would have to multiply that bracket 10 times, and that's a lot of work. So I'm going to try using the chain rule. So f of x, I'm going to do f prime of x for the derivative. First thing I'm going to do is focus on what's inside that bracket. I have 5 plus 3x. So I'm going to take the derivative of 5 plus 3x. So the derivative of 5, that's just a number, so it's 0. And then the derivative of 3x would end up just being a 3. So that's going to be 3. That's the derivative of the bracket. And then times the derivative of the whole function. So it's kind of like using power rule. Sometimes we call it the extended power rule. I would do 10 times the coefficient. There isn't one, so that's just going to be 10. And then I take my bracket, so 5 plus 3x, to the power of 1 less, so 10 take away 1 is 9. And then I would multiply the 3 and the 10 together. I can't multiply this bracket because it has an exponent on it, so unfortunately I can only do the coefficients in front. 3 times 10 is 30, and then times 5 plus 3x to the 9. And there's my derivative in factored form. Okay, let's take a look at the next one. So I have f of x, again, this one is 20 times x squared plus 10x minus 1 to the power of 7. So, to do the derivative, f prime of x, I'm going to start with what's inside the bracket. That's the x squared plus 10x minus 1. And we're going to take the derivative of x squared plus 10x minus 1. So the derivative of x squared is 2x. The derivative of 10x is just 10. And then the derivative of 1, that's just a 0. Now there are 2 terms, so that really does need to go in a bracket. And then I'm going to take the derivative of the whole function. So we're going to do 7 times 20. 7 times 20 is 140. And then my bracket, so x squared plus 10x minus 1. And then I take 1 off the exponent, so that's to the power of 6. Oop, can't see that. Now, should I multiply 140 and the 2x plus 10? If I do that, it's not factored anymore. At least right now it is factored. On this one, I had monomials, so single terms, and the singles like to mingle, so I will multiply those together. But if I have binomials or trinomials, I do not multiply. The only thing I might do is move the monomial up to the front. So I'm going to say f prime of x is 140. Now the 2x plus 10 is actually not fully factored, right? I can divide both of those by a 2. So I think I'm going to divide out a 2. So I'm going to say this is 2 times x plus 5 times x squared minus 10x minus 1. By the way, this does not factor. There are no 2 numbers that add to negative 10 and multiply to negative 1. If it wasn't factored in the beginning, I wouldn't worry about factoring it here. Last thing I would do is, because I have factored this, I can now multiply the 140 and the 2 together to get f prime of x is 280 times x plus 5 times x squared minus 10x minus 1 to the 6. And there is my final derivative in factored form. Okay, I think we're going to stop this video here, and then I will catch you in the next one to do the last 2 examples.